Hello everybody. In today's video we are back with the Dell Inspiron 620, the 12-year-old free computer that I showed in a previous video. In today's video we are going to be doing something very cool and unique with this computer that is new territory for me, something I've never done before. We are going to turn this computer into a big, powerful router. And we're going to do that using some special hardware and some open source software. Now, before I go any further, I should say, and this is mostly for strangers who come across this video that aren't my subscribers, this video is going to be more of a show and tell and not a how-to video. You're going to see me go through with installing the software that we're going to run on this computer, and then I'm going to poke around a little bit inside it, but I'm not going to go much deeper than that. And this is mostly because I'm not a networking expert. I think I probably know more than the average Joe, but only very slightly, and that's because when I was in high school, I had training that prepared me for the Cisco CCENT certification. But I never tested, I never got that certification, but I did get the training that would have prepared me to take the test to get that certification. Cisco CCENT doesn't even exist anymore. They want you to go straight to the CCNA now. So I did have that training, but that was almost 15 years ago. And I haven't worked. Well, I actually did. My last job was technically in IT, but I did very little networking stuff, and I hope I never have to work in IT again because the security side of it was just a nightmare, and I never truly knew if I was doing things right, and I hope I never have to do that again. Internet security is just something I don't even want to try to learn. So yeah, this is not going to be a deep dive, it's going to be more of a show and tell. Now, the first question you may ask is, why do I want to turn an old computer into a router? First of all, mostly just because I can, but there is something useful that I can get from this. In this building, there are 3 of us that live here, and we all share a single internet connection, and it's great. But naturally, with me being me, I have vintage computers and other unorthodox devices that sometimes I would like to connect to the internet. And obviously, there is at least a little bit of security risk that comes with that. But, you know, on my modern computers, and on my phone, I can, for example, see someone else's printer that's connected to this network. I can see someone's smart TV. And I want to keep myself separate from those things. Not only because those people have those things and I can see them, but I'll have things connected like vintage computers and other stuff that I don't want the other people to have access to. It's just better for everybody if I could have my own local network that in turn connects to the main router that serves this building for internet if I want something to have internet. So that's what this thing's going to be. Now, I presently do have my own local network. Right outside of my door there is a little Wi-Fi extender thing that comes with, you know, when you get a Bell internet connection, they give you the router, and then they give you what they call a pod that connects via Wi-Fi to the router, and it extends the Wi-Fi signal. Well, that pod also has an Ethernet jack on it, so you can hardwire something to the pod and get it to the network that way. So what I did recently was I had this big bundle of Cat5 Ethernet cable that I got for free. Not Cat5e, Cat5, the old stuff that's only rated for 100 megabit per second. I had this great big long bundle of it, and so I put ends on it and I connected it to this pod that's right outside my door, ran the cable inside my door up into the ceiling all the way across my ceiling to the other end of this apartment into this room, which is my home office, and it drops down from there. So I have my own cable going ultimately to the router that serves this building. Now, it's still ultimately having to hop over Wi-Fi from that pod, but there's still a benefit to being able to have a cable, such as obviously me being able to attach a router and make my own LAN that's separate from all the other devices in this building. Now, I do have a router that I am currently using for this purpose. It's a Linksys WRT54G, best router ever made in my opinion and a lot of people's opinions, and it works just fine for that purpose. But it's all obviously a very old router. It's one of the versions of the WRT54G that can't run DDWRT, which is open source firmware. So because the hardware is too limited, so I don't have the benefit of DDWRT on that router. So I thought, well, why not, if only for the fun of it, but possibly also for the benefits of having gigabit speeds, so I can access the full speed of our internet connection. We have 500 megabits per second down, 500 megabits per second up. So for those benefits, and also just for the fun of it, and I've got this free computer sitting here doing nothing, why don't I turn it into a router, which is something you guys can do with any semi-modern old computer. So there's two things that we need in order to do that. The first thing is we need at least 2 Ethernet ports on this computer. There's one built onto the motherboard, but that's it, as with most desktop computers. So we are going to install a server grade piece of hardware. It is this Intel Pro 1000 PT. It is a dual interface Ethernet adapter, PCI Express. And yeah, this is basically 2 separate Ethernet network interface cards on a single card. And so we are going to install that in this computer, and that'll give us a total of 3 Ethernet jacks. Now, what about the software side? We are going to install a free open source piece of software called OPNsense. It is a variant, it is based on FreeBSD, I think actually a hardened version of FreeBSD. And it is custom software that'll basically turn whatever computer you're running on into a very powerful, very customizable internet router. And it can make use of any interface that's built into the computer, no matter how many you have. You can also get these cards in 4 interface versions. So if I had one of those, we could have 5 ports in this computer. And you can do things like have multiple WANs, multiple LANs, you know, like I'm going to have 3 jacks in this computer. I could make one into a LAN for the modern computers and one into a separate LAN for the vintage computers, just as an example. And there's so much customizability. It's got a very powerful firewall, lots of configurability, and I'm just not going to be able to show hardly any of it to you because there is so much you can do. It is such a powerful piece of software, and I don't have the knowledge to make complete use of it. But that's what we're going to do today. We are going to install that dual Ethernet card. We're going to install OPNsense, and we are going to turn a 12-year-old computer into a router. And it should be pretty fun and pretty cool, so let's get started. What I've done is I've actually upgraded this thing to, it originally had 6 gigs of RAM when I got it. I have now upgraded it to 8 gigs of RAM. And for those wondering, I did find a couple of 8 gig sticks, so I tried them to see if I could get 16 gigs of RAM in this thing. One stick it didn't detect at all, the other stick it only detected as being 4 gigs, so it looks like 8 gigs is the real maximum for this thing. Now, does a router need 8 gigs of RAM? Is 8 gigs versus 6 gigs really going to be a difference? Well, people run OPNsense and pfSense on some crazy powerful computers, and they do that because those computers are routing a serious amount of internet traffic, you know, 10 gigabit per second networks with dozens or hundreds of clients. That's a lot of traffic that has to be routed, and if the computer is too bogged down, it slows down your network speed. For me, this thing's going to be running probably typically one modern computer and one or two vintage computers. So I don't think it's going to make that much of a difference. To that end, I think I'm going to take out this 160 gigabyte hard drive. And once again, people will recommend that if you're doing some real serious, like if you're in a professional environment building a router out of a PC, you'll want to get an SSD. For me, mechanical hard drive is just fine, but I do think I'm going to pull this 160 gigabyte drive, and for nothing more than the fun of it, we're going to install this circa 2005 Hitachi DeskStar SATA 150 drive. This is hilarious. Smallest SATA drive I've ever had, 40 gigs. And is 40 gigs gonna be enough for a router? I think it certainly should be. So we're gonna swap this guy in just for the fun of it, because it's the oldest, smallest SATA drive that I have. And yeah, so I'll make those changes, I'll install the card here, and when we come back, we'll start installing OPNsense. Alright, here we are, and it's actually a couple of days later. This video actually almost screeched to a halt before it even began, because I actually had to deal with some pretty severe problems that were that was making OPNsense completely refuse to boot on this computer. I tried multiple versions. I tried the normal version versus the DVD version, and OPNsense just absolutely refused to boot on this thing. But funny enough, I tried pfSense, and pfSense worked okay. It booted to the installer, but when it got to the part where it partitioned the hard drives, the pfSense installer acted very weird. So I decided to try something. This computer was running a very old version of its BIOS, so I updated it to the latest version. There was like 6 versions in between, and that actually solved the problem. The OPNsense installer works perfectly now. It's the first time I've ever seen a BIOS update make a tangible difference in the usability of a computer. Very, very interesting. But you can see here our 40 gigabyte hard drive is detected and working. So now we just boot to the OPNsense installer. It's on a USB now instead of a DVD. So I will just boot that. And here we are, and it's going to automatically start booting. We're on version 23.7. And if this console text looks very blurry to you, it's just as blurry in person. There's some sort of weird aliasing going on. Maybe it looks okay on an LCD monitor, but on this CRT it just looks kind of like crap. But that's okay. We can read it, and that's what's important. We have a mouse pointer now, which is kind of funny because we're still in console mode. So what it's actually doing right now, it's booting the actual OS, and you can actually use it like that, like right off the USB stick. And that's the little ditty it plays to tell you that it's done booting. yeah, you can actually use it just like this. It is running now on this hardware, even though we haven't installed it yet. But we do want to install it to the hard drive. So we're going to log in as installer, and if I remember right, the password is OPNsense, all lowercase. And indeed it is. And so yeah, it turns out you actually need a minuscule hard drive to run this. I mean, I wrote the installer to a 16 gigabyte USB drive, and the actual image is only, I think, 800 megabytes. And on the OPNsense website, in the documentation, they give a minimum hard drive size of 4 gigabytes, so you don't need much hard drive space at all. So that's just for our keyboard. I'm going to choose the default option, and we're going to install it to this hard drive. Sure. Yes. And away it goes, formatting the hard drive. Alright, and here we are. We won't bother changing the root password for now. We're just going to exit and reboot. Rebooting in 5 seconds. And of course it shows us how we can access the web interface. I'm going to yank my USB out. And you can see it's just like booting the install image. It's the exact same process, because the install image is also just a live image of the system. And there we go. We are in again. So we're going to log in as root. Oops, and the password is not root. Is it OPNsense again? Yes, it is. So it's already informed us that our LAN IP address, or the IP address of the router on the LAN, is 192.168.1.1 with a subnet mask of 255.255.255.0. And it gives us a little menu of what we want to do. And really the only thing we have to do in here, you know, if we're just doing basic stuff, is to assign our interfaces, which is option 1. So I will hit 1 and enter. Do you want to configure LAGGS link aggregation? No. Do we want to configure VLANs? No. If you do not know the names of your interfaces, you may choose to use auto detection. In that case, disconnect all interfaces now before hitting A to initiate auto detection. I don't want to do auto detection. I want to make a specific port the WAN port and have the other two be LAN ports. So it actually listed our 3 interfaces right here, 2 on that card I installed, and then the internal interface, which we can use. We can deduce that on account of the names being EM0 and EM1, that's the interfaces on the card, and then RE0 is the one on the motherboard. But of course it also informs us that EM0 and EM1 are on the Intel Pro 1000 PT card, that's the card we installed, and RE0 is the Realtek chip built on the motherboard. So I want to make that, just for the sake of simplicity and knowing what port's what, I want to make the onboard port the WAN, so that's RE0. So enter the WAN interface name, we want the WAN to be RE0. Enter the LAN interface name, or A for auto detection. We'll just type EM0. Enter the optional interface name, or A for auto detection. So the optional interface, because we already have WAN and LAN, what's left? Well, if you have more than 2 ports, as we do, we have 3, you can create an optional interface that you can configure to do for other stuff. I think you can probably configure it to be a second WAN for load balancing or redundancy. So I'm just going to type EM1, and it's asking for an optional interface 2 name. That doesn't exist, we only have 3 ports, so I'm just going to hit enter. And it shows us what we configured. Do we want to proceed? Yes. And there we go. We're pretty much done. So at this point we can log out just for security purposes. And what I should be able to do at this point is I've got my, is this it or is it the other cable? It's the other cable. I've got my cable going to the world right here, which in my case it doesn't actually go to the world, it goes to the main router that serves this building. And I'm going to plug that into my WAN interface. And I'm going to take another cable, plug it into my LAN interface. We're going to switch to another computer where I should be able to log on to the web interface for this thing and configure it just like any other router. Okay, here we are. We're on my main computer, which I have connected to the LAN port of the computer. And if I do an IP config here, we can see that it worked just like any normal router. I plugged it in and it immediately gave me an IP address through DHCP. We've got our gateway address here, which we can use to log into the web interface. And yeah, right away we are on the internet, no problem at all. So let's go and log in. And the login is username root and password OPNsense, again, all lowercase, and you would obviously want to change that in a production environment. And when we log in here, we are greeted by a dashboard screen, which is very cool. We get some system information, the hardware specifications of our computer, what our uptime has been, CPU usage, memory usage, swap file usage, and overall hard drive usage. And as you can see, at least in my case, OPNsense uses 2.1 gigabytes of hard drive space, so not very much at all. We get a list of our services, which are down and which are up, and you can also reboot or stop services if you want. I disabled DHCP, or I disabled IP version 6 stuff, so the DHCP version 6 service is not running. If we scroll down here, we can show our gateways and whether or not they're online, our interfaces, which are up and which are down, and what the IP addresses are. My WAN address, you'll notice I have a 192.168.2 address because once again this router is being plugged into the main router, which serves this building. And then you can add what are called widgets, and there's a lot of them you can add, and I added a couple here. One is this CPU usage graph, and then a very cool one is this traffic graph, which shows you the amount of traffic being carried in and out of the network. Very customizable as usual. We have reports, various reports that you can run. And lots of configuration. Look at our interfaces. We can customize how our interfaces work if they have services such as DHCP enabled. The speed and duplex settings, we can force it to 100 megabits or even 10 megabits if we want. And of course, remember we've got this option 1 interface because there's 3 ports on this computer. We've already got a WAN, we've already got a LAN, so we have option 1 as the extra. And what I thought I would do, or thought I could do, and technically I can, is I read that you can bridge 2 interfaces on the same LAN and basically make the computer act like a switch in addition to a router. But unfortunately, OPNsense really doesn't want you to do that. You can do it, but it requires jumping through hoops, and I think you got to go into the command line and do stuff, and it's just kind of a pain in the butt to do. What they really want you to do, and for good reason, is to just buy a real network switch and extend your LAN across multiple ports that way. But if I were to go into other types, there's a bridge setting here, and I actually did make a bridge, but it's not doing anything, so I never finished configuring it, so I'll just delete it. But if you wanted to bridge two interfaces to act like a switch, that's where you could do that. Lots of other settings here, and of course we get to our firewall. Now the nice thing about OPNsense and its commercial-oriented counterpart pfSense is out of the box they are configured like a standard home router, meaning they are secure, nothing's open. It's all closed off, so you can establish connections to the outside world, but the outside world cannot establish connections to you, and that's a good thing. So like if we go to firewall rules, let's go to WAN, and you can see there's no rules that I've put in manually, but you can see there's a bunch of custom generated rules, and that allows stuff like pinging to go through and DHCP and all that stuff, but otherwise it's completely closed off by default, which is good, so you don't have to be scared using this thing wondering, you know, if you have an OPNsense router immediately facing your internet without something else in between, you don't have to worry about, is this safe? Out of the box, it is safe and secure. All our services that we can configure. I customized my DHCP range to go from 1.10 to 1.20. We can specify our own DNS servers. There's just so much you can do, and I do not have the time or the skill or the knowledge to demonstrate even a fraction of it to you, but it just goes to show how much you can do, especially compared to many other, you know, off-the-shelf routers. And then finally, we do have the option of rebooting and powering off the computer, which is nice. You can also check for updates, which after I installed this, I did a check and there were a few updates to install, but you can see it gives us a console printout here. And it says there are no available updates. So good, we are fully up to date. And yeah, there you go. There is a ton of stuff that you can do in here. Make it work exactly the way you want it to. I don't have the skill to show it all to you, but hopefully you can get a sense of just how powerful this software is. Well, that's it. We have successfully turned this 12-year-old computer into a functional router. And I gotta say, there is a lot that you can do in OPNsense, far more than I know how to do. And so it's a great thing that by default it's all locked down, and by default it just works. The only thing you have to do out of the box is tell it what interface is going to be your WAN, which one's going to be your LAN, and after that you just plug in a computer or whatever client and it does DHCP and gives you an IP address and you're on the internet. That's fantastic. And there's just so much you can do with this. It's been very fun getting this running and taking a look at OPNsense for the first time. I am going to button this thing up, stick it somewhere under the table here, and I am going to use it as a router. I will get a hardware switch like this Cisco Catalyst 2950, which we may look at in a future video. And yeah, I mean, I might as well do it. You know, it doesn't hurt to be able to have my equipment on its own network. I've got a Linksys WAP11 802.11b wireless access point. You just plug it into a switch and you get Wi-Fi, and so I can plug that into this thing, and I can put my vintage computers that have Wi-Fi capabilities on Wi-Fi. It's great. So yeah, I've got nowhere else or no way else to use this computer, and I'm not going to sell it because a friend of mine gave it to me for free, and I don't have anyone right now who wants a free computer. So I will tuck it away, and I'll use it as a router. OPNsense seems to be pretty darn cool. Now, this may be quite a big router. It takes up quite a lot of space compared to something from TP-Link or Netgear that you can go on Amazon and buy pretty cheaply. But I have, for example, this mini ITX computer that I built a few years ago from an HP motherboard. It's got an onboard Ethernet jack. You could buy a $20 USB Ethernet adapter, plug it into one of the USB ports, and now you've got a router that could run OPNsense, and it doesn't take up a whole lot of space or use hardly any power. So something like this would be perfect for that. I assume this could run OPNsense. This is actually about the same age as that, but it's got a far worse CPU. It's an AMD E300 APU, I think, but I assume this would also run OPNsense just fine. And yeah, that's about it. Now, there is one more thing I want to try. Now, pfSense and OPNsense both try very, very hard to make old versions as impossible to find as possible. And that's for an important reason. That's for security. New versions come out because they find more security flaws that they then patch out, and some of those get pushed over as updates, but some of them come over as entirely new versions, and new versions add support for newer hardware that has better security stuff, like the newest CPUs that have, you know, certain new security features, and they discontinue support for the old stuff that might not be as secure for today's needs. So they make it, they both do not host personally any old versions of OPNsense or pfSense, but I was able to find, I had to dig for a long time on the internet, but I found an old version of OPNsense, the last version that supports 32-bit CPUs. And so I'm going to do some testing with it. I got to find out just how old of a computer can you run this last version. It's a 2019 version of OPNsense on. And if it turns out that you can run it on a pretty darn old, like, vintage computer, I may make another video of turning a vintage computer into a router using OPNsense. No, you should never do it in a production environment. You should never use an old version of OPNsense or pfSense. But for me, because I'm already behind another router, really the security risk is very, very minimal. So that might be something I look into, and there might be a video about doing that. It'd be pretty cool if I could turn, you know, like a Pentium 2 system into a router. But I don't know. I did hear that even though it supports, or I did read, even though it supports 32-bit CPUs, I think it requires a very specific instruction that only the very most modern 32-bit CPUs use, so maybe a vintage computer is just off the books entirely. I don't know, I'll have to check that out. But that's it for now. Thank you so much for watching and coming along with me. And yeah, if you have any interest in networking, or if you're like me and you think it's cool but you don't know a whole lot about it, you should give it a try, and it could be a good learning tool after all. But it's certainly been fun to play around with. So that's it. Thank you for watching, and I will see you guys in the next video.